Today we're going to learn about 2.3, analyzing graphs. So we're going to talk about domain and range. Domain is your x values and range is your y values. When you see an open dot on a graph, you're going to use parentheses, and when you see a closed dot on a graph, you're going to use square brackets. Example 1. We're going to state the domain and the range. So go ahead and copy this picture. And if you need to have the sub pause the video at any point, you just let her know. So the domain of this function is where your x's are, which is going to be you're looking at your x-axis and where those values fall on your graph when you look at the x-axis. So if I do my domain, I'm going to go look at my -5, I'm going to go up to the picture, I see that is my far left. I'm going to go to the far right of the picture and find the domain goes to 5. I'm going to look at my dots. I get a closed dot at -5 means I have a square bracket, and I have an open dot at 5, so I'm going to use a parentheses. Now let's go look at the range. The range, I've got a -2 as my low point and a +5 is the high point when I look at the y values of that picture. Both of those do not have open dots. They are a continuous part of the graph, so they're going to be closed. Both are going to have square brackets. Okay. If we go too fast again, ask the sub to pause it so you can finish drawing the picture and getting down the information. Okay, vertical line test. We use this to determine whether or not a relation is a function. Vertical line test. So we're going to take example 2. The question is the graph a function? And I'm going to give you 3 pictures. A circle, a polynomial, and a piecewise function. If we look at the first one and we take a vertical line and go up and down, we see that that picture hits twice on the circle. That makes it not a function. The second picture, if we draw a vertical line, it hits once. That makes it, yes, it is a function. Okay, the third one. Draw that vertical line and it goes through the open circle, so that's not a hit, and hits the closed circle. That makes it, yes, it is a function. Okay, zeros of a function. Zeros are a function when you can set f of x equal to 0. So example 3 is to find all the zeros. So our first function is f of x equals x squared minus 7x plus 10. So if I set that equal to 0 to solve, I'm going to make sure that I look at that x squared and factor. Once I get it factored, I set each parentheses equal to 0. And I solve each one for x. Let's do another one. Let's let f of x equal the square root of 12 minus x squared. When I set that equal to 0, I square both sides, I move the 12 over, and I take the square root of 12. I have a factor tree that I need to simplify my radicals, and I get plus or minus the square root of 2, square root of 3. You want to make sure you're giving exact answers here. We don't want decimals. We want to make sure that we give an exact answer. Okay, example 3. Part C, let's use f of x, we're still finding zeros, remember, equals 2x minus 6 over x plus 4. Okay, what we want to do on this one is set the entire thing equal to 0. I don't want you to just make a habit of setting the numerator equal to 0. I want you to think about the entire mathematical process here. If you set the entire thing equal to 0 and multiply over the denominator, you make the denominator turn into 0. Which is why the numerator is set equal to 0. So understanding that mathematical process is helpful. Alright, so divide by 2, x equals 3. Be sure to check your answers, especially when we're dealing with fractions and radicals. We want to make sure those answers make sense. You can check them in the calculator. You don't have to put them on the paper to check. You can put them on the paper, but the idea is that you've looked over the answer to make sure it makes sense. Okay, next we're going to talk about increasing, decreasing, and constant. Increasing is when you have a positive slope. Decreasing is when your picture has a negative slope. Constant's when you have a 0 slope. And when you're doing increasing and decreasing and constant interval notation, you need to make sure that you only use the x values and you only use parentheses. From our pictures, we're also going to be able to talk about maximum and minimum. On those, we look at the y value at a specific x value. You want to be able to use your calculator to do this. So here's a quick review of where you find that information. Put your function into y equals, press enter, look at the graph, locate the max or min, press second table, and then decide whether or not you need to use the maximum or the minimum function in order to find what you're looking for. Then you're going to look at the bottom of your screen and follow those directions. It tells you whether or not to go to the right or the left and when to push enter. All right, example 4. We're going to talk about this increasing and decreasing more specifically with a picture. So sketch this picture. It's a piecewise function. I keep talking about piecewise because we're going to do piecewise at the end of this lesson. So we're going to find the increasing. Here's the question written in black for you. Decreasing. And constant. So before we write the answers, let's look at it. Increasing. Where do you have a positive slope? Now there's two sections here. You've got one that goes from negative infinity to negative 3. Now remember, I said on the previous screen, we need to only look at the x values. So, from negative infinity to negative 3, that's a positive slope. Let's go look for the next positive slope. Where does it start? 2. And we go from 2 to infinity. And I also said on the other screen, only use parentheses. Now let's look at decreasing. Where's the negative slope? The x value for the negative slope goes from 0 to 2. And the constant is from negative 3 to 0. Now we also want to talk about any relative max or mins that we have. So here's writing out the increasing and decreasing we just talked about. The constant goes from negative 3 to 0. And then the relative min. It's negative 2 for the y value at x is 2. So you write that a little differently than what you've been used to. The next topic is average rate of change. Average rate of change simply means slope. It's just a different word. So you've got to start working on this vocabulary. So when you read a question, you know what I'm asking for. And then a reminder of that formula is m equals y2 minus y1 over x2 minus x1. Keep in mind your x's are going to be the time that something is happening, so go ahead and use time in the x location. Alright, let you finish that slide before we go on. Okay, so let's move on to section 2.4. 2.4 is talking about parent functions. You've got 2 more slides left. You can hang in there with me. Example 1. Write the linear function f for which f of 1 is 3 and f of 5 is negative 1. Alright, we got to remember what we're doing here. We know how to write a linear function. We know that the slope is m equals y2 minus y1 over x2 minus x1. We know the equation of a line is y minus y1 equals m times x minus x1. We did that before we stopped and did the ACT review. We're going to use the point slope form. Remember, I don't like to use y equals mx plus b, but you can. There's not a problem with that. Alright, so here's what we're given. Let's look back at it. See if you agree that we were given 1, 3, and 5, negative 1. Look back at that f of 1. Whatever's after the f is the x. The other side of the equals is the y. So then look at the f5. f of 5, that means that the x is 5 and the y is negative 1. There's our x1, y1, x2, y2. So we can find our slope with that information. We can then write our equation with y minus y1 equals net m x minus x1. We can distribute, we can add over the 3, and write our equation in slope-intercept form. So first find your slope, and then write your equation. That's for linear. Alright, let's move on. Let's make sure that we use our calculator to graph and make sure that we're getting things right. We don't want to use our mental math and mess up and not be able to do this correctly. So when you put it in your calculator, you want to make sure that you use enough parentheses to get it right. So in example 2, and ask us to sketch a graph. We're going to be sketching this piecewise function. Here we go. Piecewise has, the reason it's called that is because it has different pieces. This one has 2 pieces. You're going to have multiple pieces on different graphs. We're going to start with 2 to get us warmed up. So go ahead and draw your grid. We're going to graph the first one in red, and I'm going to make a table. You pause it so you can catch up with me. Okay. So first you're going to take the x plus 5 as x is greater than 1. Sketch your graph. Alright, so I take that x plus 5 and I make a table. I look at x is greater than 1. When x is greater than 1, those values would be 1 and 2 and 3 and so on. So I'm just going to do 1, 2, 3 and put them on my table. Okay, so if I put a 1 back into x plus 5, I get a 6. When I put 2 back in, I get a 7. And 3 back in, I get an 8. So now I have a table of points that I can plot. So let me do that. I'm going to keep in mind that that is an open circle because the greater than was not underlined. Alright, let's look at the second one. So I start at 1. And I'm supposed to go smaller. So go from 1, because you got to use the one you're given because that's the open and the closed circle information. So I'm going to use 1 and smaller, 0 and negative 1. I'm going to go find the y values and putting them into the negative 2x minus 3 formula. Okay, and I'm going to keep in mind that's a closed circle because x is less than or equal to 1. I'm going to draw that picture. So now I have a piecewise function. And from this I could tell that it is a function. I can do my vertical line test and double check it. I could talk about increasing and decreasing of it. So we're going to be able to use everything from 2.3 and 2.4 put together and be able to work these questions. We're also going to need to be able to do word problems with them. So we want to make sure that we're kind of piecing it all together and being able to do more than one thing with one picture and one topic. Okay, you're going to get started on your homework now, so whenever you get out your calendar, once you get out your book, and I want you to work on your homework. Make sure that you have questions ready for me when I come back on Wednesday, and I'll be able to do a couple more piecewise with you or work a couple of word problems. But make sure you've worked your homework so you know what to ask. We will do homework checks as soon as we finish homework questions, so things are just back to normal. And if you have anything that's pressing, you're welcome to email me or come find me during seminar tomorrow. I'll be back in town on Tuesday, so you can come find me during seminar. Remember, I'm down in the North Commons, over by the cooking rooms and the entrance to the cafeteria. So if you need a pass, there's some the sub can write for you in the desk drawer. Okay, you'll have a great day. Bye.